Good morning, everybody. It's 1 minute before 9 a.m. in Arizona. And if you're joining us about the Q&A about the geology of the Grand Canyon, we'll be starting in just about 1 minute. So I wanted to come on live just a minute early just to see if everything was working okay, and it appears that it is. I can see that there's already 3 viewers. Thank you for joining us. And we'll be starting momentarily. There's lots more people joining in. The numbers are climbing. 8, 9, 11, 15. Jan Schultz has joined. Haley Johnson has joined. Beth Rambakur. Thank you, Beth. Well, good morning, everybody, and welcome to Learning Geology. My name is Wayne Ranney, and I am a Grand Canyon geologist, educator, and author. And it's my distinct pleasure this morning to take up about 45 minutes or an hour of your time during this stay-at-home pandemic and talk about the Grand Canyon. And I'm sure that many of you have visited the Grand Canyon, or maybe some of you hope to join the Grand Canyon, visit it one day. Today we're going to have a question and answer. I can see questions as they come in. I'll give a brief introduction about the geology of the Grand Canyon, and then we'll start to answer some questions. And I do want to mention that this will be recorded and available on Facebook to watch at a later time. So if you find it informative and interesting, you can ask people and let them watch it later on. Please, when you do make a comment, give your name, at least your first name, and tell me where you're writing from. It's nice to know where people are watching from. And as you know, Learning Geology is a Facebook page that is hosted by Mohammed Qasim Mahmood from Lahore, Pakistan. And we probably have some people watching from that part of Asia. I was lucky enough to fly over Pakistan. I've never visited the country yet, but I've been lucky to fly over the country of Pakistan. And as I looked down from 30,000 feet, I could see landscapes that looked a lot like the American Southwest. And of course, in the northern part of the country is the Himalaya Mountains. So probably a lot of geology enthusiasts there from that part of southern Asia. I wandered into the Grand Canyon about 45 years ago as a young 21-year-old boy and got a job as a backcountry ranger and did that for 3 years and got interested in geology. And then I started to study geology formally at Northern Arizona University and began a career in sharing geologic thought with people who were non-geologists. So this is the perfect forum for a person such as myself who loves geology, but equal to that, loves sharing it with other people. To begin our discussion of the Grand Canyon, first of all, the Grand Canyon is located in the southwestern part of the United States, and the Grand Canyon is also located in the southwestern part of the Colorado Plateau. So for any of our international viewers that might be looking in this morning, this is a map of the United States, and it shows the physiographic provinces of the United States. And if the United States had been divided into states that were based on their geography, each of these separate colors would be their own state. And right down here in this dark blue outlined in black is the Colorado Plateau. And Grand Canyon is located on the Colorado Plateau. And here's a map of the Colorado Plateau. And you can see where the Grand Canyon is located there in the very southwestern corner of the Colorado Plateau. So the Grand Canyon is about 277 miles long. That's more than 400 kilometers long. It's on average 10 miles across, which is 16 kilometers wide, and it's about 1.6 kilometers deep, or a mile deep. And it is probably the single best place on planet Earth to get a huge sweeping view of Earth history. And through the nearly 2 billion years of Earth history that's recorded in the Grand Canyon, you can see it all from standing on the rim and looking down to the very bottom and seeing the oldest rocks. So to begin our discussion, you probably should know that the Grand Canyon has 3 different sets of rocks. And they're color-coded here on this diagram. And at the very bottom, you can see a light green color. That light green color represents the Precambrian crystalline rocks. Sitting in angular unconformity on that is the Grand Canyon supergroup. That group of rocks is colored in orange here. And then by far, most of what you see when you look into the Grand Canyon is this blue layer of rocks right here. And this makes up 4/5 of the walls of the Grand Canyon. 1/5 is down here at the bottom, 4/5 right here. And these are sedimentary rocks that were laid down during the Paleozoic era. And those 3 packages of rock are the important rock layers of the Grand Canyon. And I'm going to talk very briefly about them. The oldest rocks in the Grand Canyon belong to the Grand Canyon Metamorphic Suite, and we give them the name Vishnu Schist and Zoroaster Granite. I have a sample of the Vishnu Schist here. I have worked as a geologist in the bottom of the Grand Canyon and used to have a collecting permit, and here you can see the mica that is reflecting light right here. And this mica is muscovite, and we believe that these metamorphic rocks used to be shale and sandstone, in some instances basalt lava, maybe even rhyolite lava, and they were buried at depth and cooked into these medium grade metamorphic rocks. It's very interesting to me. Early in my career, I did not like these metamorphic rocks because they didn't reflect much about what was happening on the surface of the earth until you look through the metamorphism and you can see what the rocks used to be. This particular rock right here sometimes has minerals of garnet that can only form at temperatures and pressures that today would be found 13 miles below the surface of the earth. So incredible to think that because of these minerals that are enclosed in the Vishnu Schist, we can understand that these oldest rocks, about 1.75 billion years old, had 13 miles of rocky material above them. And there were even rocks lower down in the crust than that were completely melted. They turned to liquid magma. And here's a sample of the Zoroaster Granite. So if you go down below 13 miles all the way back there in the Paleoproterozoic, rocks that were 15 or 18 miles down below the surface melted completely. The hot, buoyant magma rose up through the schist and sometimes cooled and crystallized there at the bottom of the Grand Canyon. I don't want to say too much about the second package of rocks, the Grand Canyon supergroup. They're only found in about 10% of the Grand Canyon, and that's because after this 2.5 mile thick group of rocks was deposited, they were faulted and uplifted and mostly eroded away from the Grand Canyon area. There were a few places where the angled faulted rocks were faulted down into that ancient landscape, and because they were down low in that landscape, these 10% of Grand Canyon supergroup rocks were preserved as wedges of tilted sedimentary rocks in the bottom of the Grand Canyon. There's about 9 or 10 different rock units that are part of the Grand Canyon supergroup, but I don't want to spend too much time on that. The last group of rocks at the Grand Canyon are the Paleozoic layers, and the Paleozoic rock layers, as I said, make up about 4/5 of the canyon wall, and they go from Cambrian to Permian, and they record all of the different environments that used to exist in the Grand Canyon. And what a fantastic assemblage of ancient environments we have preserved there. I don't know if these will show up very well, but during the Cambrian period, this part of Arizona was part of an ancient beach. And you can see the outline of the states here. This is the outline of the state of Arizona right here, and the Grand Canyon would be located right in this area right here. But look at this. This is the continent of North America. This is the Paleo-Pacific Ocean, and about 500 million years ago, that's what you see what the Grand Canyon area looked like. Later on, during what most geologists call the Lower Carboniferous, here in North America, we call it the Mississippian. The entire southwestern part of the United States was mostly underwater. It was just this one area right here where you had the transcontinental arch. All of this is shallow marine water, and this is where the red wall limestone was deposited. Later on, during the Permian, we had Aeolian dunes being laid down. All of that light yellow that you see right there is windblown sand. Just think, back in the Mississippian or the Lower Carboniferous, this was all ocean water. There you see it as a nice desert. And then the very top layer at the rim of the Grand Canyon is the Kaibab limestone. And you can see that once again we return to mostly marine conditions in the Grand Canyon area right in here. So that's a little bit about the paleogeography. There were Mesozoic rocks that used to sit on top of the Grand Canyon, but all of us got here too late to see those Mesozoic rocks at the Grand Canyon. There may have been as much as 10,000 feet or 3,000 meters of additional sediment that used to sit on top of the uppermost layers at the Grand Canyon. And that brings us to the final part of the story, which begins about 70 million years ago. 70 million years ago, this great interior seaway that used to exist in the interior portions of North America retreated away, and the Grand Canyon area was at sea level, but at that time, the Colorado Plateau and the Rocky Mountains began to be uplifted. And during this initial uplift is when the very topmost sediments, either the end of the Mesozoic or the early Cenozoic, were eroded away off the top. And for the last 70 million years, we've been stripping rocks away off of the Colorado Plateau. And during that time is when the Grand Canyon was carved. I hope we get some questions about the carving of the Grand Canyon, because certainly people are interested in that. So that's a little bit of an introduction to the Grand Canyon. I see we have Mehmet joining us from Turkey and Pacific Northwest here in North America. Hello from Ohio. Hilda from Indonesia is looking in here. And Louisiana. Grand Canyon brought tears to my eyes. Thank you, Ray. I think it does for a lot of people as well. Scrolling down here for any questions. Cynthia Bauer, hello from Manitou Springs. Love that. Okay, everybody's just writing in to tell me where they're from. Serbia, Georgia, Bahia Blanca in Argentina. Gracias. Panama, Wheat Ridge, Colorado, Nicaragua. Telluride, Colorado. Okay, here's the first question from Dennis. This is Dennis from Flagstaff, right down the road from where I am. Why is it that miners didn't much, if any, find gold or silver in the Grand Canyon, but did find copper and asbestos? Thanks. Well, that's an interesting question, and I've thought about, if the Grand Canyon metamorphic rocks had contained gold, think how different the human history of the Grand Canyon would have been. If those early Spaniards who came here in the 16th and 17th century had found gold in the bottom of the Grand Canyon, it's fair to say that there would be great mining areas in the bottom of it. But as some very intelligent miners used to say, gold is where you find it. And there's a lot of studies that have gone on why some magma intrusions that come into the upper parts of the crust contain valuable minerals like gold and silver, the same kinds of rocks elsewhere will not have them. So fortunately, I think, for the preservation of the Grand Canyon and its protection, there was no gold or silver that was found in the rocks. But as Dennis mentioned, they did find asbestos. The asbestos was from a magnesium-rich limestone that came into contact with hot magma. And when the hot magma came in, it interacted with the magnesium-rich limestone, and it created a rock called serpentine asbestos or chrysotile. So we have the right rocks and the right conditions to create the asbestos. The copper that was found in the Grand Canyon was brought in during this initial mountain lifting event that began 70 million years ago, and that's called the Laramide orogeny. And the Laramide orogeny, while the landscape in the American Southwest was being uplifted, what happened is these valuable minerals were emplaced in some of the limestone rocks that we have in the Grand Canyon. Let's see what else we have here. Ty Maloney, 29-mile canyon, and the side canyons within the Grand Canyon are named on their mileages downstream from Lee's Ferry. So 29 miles downstream from Lee's Ferry in the Grand Canyon has a bowl at the eastern end of it. Could this be a drainage feature? I'm thinking that Ty is probably a river guide in the Grand Canyon, or at least a river runner. And yes, I have seen that bowl. And it turns out that a lot of times these bowls or amphitheaters, as Clarence Dutton called them, form where spring water comes out of the base of the red wall limestone. It degrades the foundation of the red wall, and the red wall is left overhanging, and you get these bowl-shaped depressions that eat back laterally into the red wall. And I'm pretty sure that that's how those things have formed. Lauren is writing in from Las Vegas. Hello from Salt Lake City, Utah Geological Association. Glad to have you along. Nick Zenter, what evidence for 70 million years ago for uplift beginning? The evidence that we have for that is that these uplifts began to occur throughout the Rocky Mountain region in the American Southwest, and as the highlands were being raised, sediment was washed into the intervening basins, and these sediments still exist on the modern landscape. And we know that they're 70 million years ago because the fossils that are found within them can tell us that the uplift was going on. So that's very interesting that we're not actually dating the uplifted from what was uplifted. We're dating the uplift from what was washed out of the uplifts. And we can also trace the western interior seaway retreating back across the landscape and when that became dry land. Thank you for that question. Can you talk about the role of the river? Emily is writing to us and says, good morning, talk about the role of the river. The way that I like to think about the role of the river is that the Colorado River is responsible for the Grand Canyon. A lot of times when I was learning geology early in my career, people said that the Colorado River carved the Grand Canyon. And while that's mostly right, what it does for people is it paints a picture that the entire hole in the ground that you see was cut by that single river. Now, a couple of things come to mind. First of all, the river that you see today is not necessarily the river that has been in existence or for all of its ancestors through time. There's been changes in climate and changes in the height of the Rocky Mountains, changes in the tectonic layout of the Southwest. And so the Colorado River through time has probably changed its size, but there's no evidence, and it would be virtually impossible for the Colorado River to be 10 miles wide as the Grand Canyon is in many places. So the way I say it is the river is responsible for the Grand Canyon. What happens is the river chisels its way down through these rocks, all of the side streams begin to come in, and the side streams themselves are beginning to carve their own side canyons. And in the Grand Canyon, it's so interesting. Most of the side canyons come into the main river at grade. They come in at the same level that the river is. And if you look at the profile of most of the side canyons have very steep upper parts, and they tend to flatten out as they enter the river. And it's almost like the side streams have more cutting power than the Colorado River because the side streams flatten out as they come in. They're almost screaming to the Colorado River, hurry up, cut down deeper. We want to go down deeper. So the vast portion of the space that you see in the Grand Canyon is cut by the side canyons. And I think you'll be able to see the geologic map behind me that I've put behind for this discussion. And the river corridor is easily seen behind me, but you can also see how big and wide those side canyons are. Thank you for that question. We got a viewer from Morocco looking in, Ganado, Arizona. Thank you for calling in from the Navajo Nation. Ted asked the question, any cave systems in the Grand Canyon area if it was part of the Great Ocean in the past? I know a hydrologist here in Arizona who says that Grand Canyon should be called Cave National Park. And there are lots of caves in the Redwall limestone, a few minor caves in the Kaibab limestone, but there is a great cavern system that exists. And yes, there are great cave systems that are here. And in fact, in many places around the world, wherever you have these very pure limestone deposits, you have great cavern systems. Utah Geological Association is asking, did the ancestral Colorado River flow to the Pacific? How did the flow path change over time? Another good question. I'm very interested in thinking about the history of the Colorado River. Let me just say this first. If you had a movie of the Colorado River through time, and you watch that movie backwards as the river devolves, so to speak, how much of that movie could you watch and then still use the word Colorado River as the name of the river? Because the farther back you went in that movie, you'd see the river change so differently than what we see today. So there is a researcher from Caltech, Brian Wernicke, who has proposed the idea that the Colorado River may be responsible for the Sespe Formation, a rock unit in northern Los Angeles County and Ventura County that has a lot of conglomerate in it, and he's found some quartzite cobbles in there that he thinks came from the Grand Canyon supergroup here in the Grand Canyon. So there is the possibility that the Colorado River went out to the Pacific. I remember a long time ago, a famous geologist from Flagstaff, Gene Shoemaker, thought that maybe the Monterey Bay submarine canyon might have been the old mouth of the Colorado River, and that area has now been translated north along the San Andreas Fault. That's one idea about that. But the one thing that we do know is that when the ancestors to the Colorado River began, and again, we can use this time period 70 million years ago, we know that the river was flowing to the northwest. To the northeast. So there were mountain ranges in southern Arizona and southern Nevada and southern California, and the lowlands trended off to the northeast. And before the Rocky Mountains came up, the ancestors to the Colorado River went for a short period of time all the way to the Gulf of Mexico into the Mississippi River system. And then not long after that, the Rocky Mountains were raised. And when they were raised, these northeast flowing streams that went across the Grand Canyon region, they were ponded in these great lakes that existed in the tri-state area of Wyoming, Colorado, and Utah. And this is a period about 55 to 40 million years ago when the Green River lakes were in existence. So we know that the earliest ancestors to the Colorado River went in exactly the opposite direction that the river goes today. Now, after these lakes disappeared 35 or 40 million years ago, we kind of lose sight of what the river was doing, and we don't pick up the river again until about 11 million years ago, when there's evidence in the western part of Colorado that the uppermost parts of the modern river were coming out of the Rockies and at least going into the Grand Junction area. So we have this period of time between about 30 million years ago and 11 million years ago where we don't really see the river, but we pick it up again at 11 million years ago. Thank you for that question. Fisher writes, I teach middle schoolers to raft the lower third with Grand Canyon Youth. That's a nonprofit here in Flagstaff. What would you recommend I share with them about the geology of the lower third? Will the Glen Canyon Dam be removed? And Tricia's writing from Fort Collins. Well, if you do the lower third of the Grand Canyon, you're going to be in the Vishnu schist and Zoroaster granite. So I think learning some stories about how those former sandstones and shales that were deposited on the ocean floor got caught up in a big mountain building event, and then the rocks were buried to a 13-mile depth. I think you want to tell that story. You probably also want to tell the story when the Tapete sandstone came in and formed the Great Unconformity with flat-lying sandstone sitting on top of these igneous rocks. And then the next question, will the Glen Canyon Dam be removed? Well, that's not only a geologic question, that's also a political question. I mean, those dams have done exactly what they were designed to do. They were designed to hold back water that came down during the late spring and early summer. And then when you had the low periods of water, you could release water from the dam and still have water for irrigation and domestic purposes. But the one thing that we've learned is that these dams were put up during a time when all of the adverse effects of dam were not considered at all. When these dams were put in during the 20th century, only the benefits were really envisioned, and even if there was a detriment to putting up the dam, it was not deemed important enough to cause that to go away. So now that we live in the 21st century, we can see that these dams are quite harmful to the ecosystem downstream from them. And if you think about it geologically, putting a dam on a sediment-rich river is very short-sighted. What's going to happen when these reservoir bodies fill with sediment? And we're not talking huge amounts of time. We're talking a few hundred years. Now, to most people, a few hundred years is a long time, but as geologists, that's just a blink in the eye. I mean, I have done this in experiments with my students. I ask them, I say, let's figure out how we're going to manage the future of the Glen Canyon Reservoir. And everybody comes up with a solution. The solution is, well, we'll just get big trucks and we'll take the sediment out of the basin. Okay, well, where are you going to put the sediment and how much is it going to cost? And then people will say, well, why don't we just dredge the sediment out and let it run down below Glen Canyon Dam? Well, all you're doing then is just moving up the speed at which the Lake Mead fills up. And once Lake Mead fills up, then Mojave Lake fills up. And once that fills up, you can see there's really no answer. Building dams on sediment-rich rivers is not a good idea in the long term. Jennifer writes, carry on, Wayne, like all those layers that are eroded away. This too shall pass. All right, thank you, Jennifer. Let's see what else we got here. I saw a documentary recently that hypothesized the Grand Canyon was formed in a matter of days from water from an ice dam in the Midwest. Your thoughts, please. Well, that's interesting. I've never heard about that before. I've never heard of an ice dam in the Midwest. We do have geologic evidence for ice dams forming in the northern Rockies, and these sometimes being catastrophically destroyed in the great big Missoula floods that went down what is now the Columbia River. There's been a lot of ideas that the Grand Canyon formed in a very short amount of time from big outburst floods. But, if you'll pardon the pun, they really don't hold water. People sometimes who are untrained in geology would like to have an answer in which the solution is based on a human time scale. And that's just not the case. I mean, even though most geologists consider the river and the canyon to be young, young still means 5 or 6 million years. Leslie's writing, Tell us if glacial processes had anything to do with the formation of the Grand Canyon. Yes, thank you, Leslie. It is likely that glacial processes did help to form the Grand Canyon, but not directly. There were no glaciers that have been recorded or evidence for in the Grand Canyon, but the meltwater in the Rockies was channeled through the Grand Canyon. And if you have these very large meltwater events that can move huge boulders, then you can begin to chisel down through this bedrock and help to make the Grand Canyon deeper. You know, one of the most interesting things that I've learned about studying the geology of the Grand Canyon is that it's not really the water in the Colorado River or even the silt and sand in the river that have carved this great gorge. It's when these relatively rare, huge floods move through the canyon and they start to roll boulders that are the size of an automobile or a dump truck or even the size of a house. And these great big boulders physically pound the bottom channel of the Colorado River and begin to chisel it down. So yes, glaciers did have an indirect effect. Elizabeth from Georgia, I teach earth science in middle school. So glad to have found this. Thank you. You're welcome, Elizabeth. So don't write in. Any fossils in the Grand Canyon? Yes, there are fossils. And in fact, I have collected this fossil of a sponge. This is from the Kaibab limestone. You can see right in the center of this rock, there's a sponge. And believe it or not, it's thought that the silica that makes up this nodule is coming in part from these sponges and help making the upper layer of the Grand Canyon hard. And that may explain why the Grand Canyon is so precipitous from top to bottom, is because of these silica-rich relics. And I better not bring that fossil up because it's holding up my map and I don't want it to fall in. I heard it took only 4 million years to create the Grand Canyon, Daniel writes. Yes, that's true. There's been a lot of recent work done by geologists at the Arizona Geological Survey and the U.S. Geological Survey that shows that the lower Colorado, that's the portion of the river from Hoover Dam down to the Gulf of California, that a lot of that portion of the river has been cobbled together by basin spillover in the last 4 million years. Now, whether portions of the Grand Canyon were carved before that can't be known from these studies, but it's, I guess it's always possible that the entire Grand Canyon was carved in these last 4 million years. But again, there's probably parts of the Grand Canyon that are much older than 4 million years from the ancestors to the Colorado River. Jeff from Durango, Colorado, can you please talk about why there's a Tonto platform in the eastern part of Grand Canyon and an esplanade in western Grand Canyon? So for those of you that don't know, inside the Grand Canyon, there's a couple of places where hikers get a break from going just straight down from the rim to the river. And in the eastern part of the Grand Canyon, it's called the Tonto platform. And it has formed where the Bright Angel Shale, a very weak shale, erodes back at a faster rate from the rocks that underlie it. And so it creates this broad, relatively flat platform. And then in the western part of the Grand Canyon, another platform is formed called the Esplanade, but this is much higher up in the section where the Hermit Shale has eroded back from the Supai group and Redwall limestone rocks below it. There's been a lot of conjecture through the years on how these platforms formed. Some of them had to do with the Colorado River before it had cut down as deep as it is today, meandering back and forth across this in a wild fashion. But it's pretty much apparent that it's really the lithology of these shales and their weakness and non-resistance to erosion that causes them to erode back at a faster rate. So it's probably erosion capabilities of the rock forms. Let's see here. Looking for more questions. Thank you, Scott writes. How thick is the layer of basement rock? Is there anything below that, or is that the mantle? The answer to that is very interesting. When you see the Vishnu schist and the Zoroaster granite, that is the rock type that probably exists all the way down until you start to get into the different layers of the earth, like the mantle that would be down there. So yeah, that's pretty thick. We're just seeing the very top about it. Let's see here. Can you talk about the Triassic rocks in this area? Okay. This is from Morocco, this question. Yes, the Triassic rocks that are here. And by the way, I've been to your country in Morocco, and your geology is just as good as the geology in the American Southwest. What a fantastic place. The Triassic rocks, there's a couple of places within the national park where remnants of the Triassic rock have been preserved. In fact, you can see one here on the geologic map. Just that little remnant right there is Triassic rock. But if you go just outside the park boundary, we have lots of Triassic age rocks. They're continental rocks, they're fluvial, they're conglomerates, they're sandstones, they're siltstones. The famous petrified forest of Arizona is in Triassic rocks. And for those of you that don't know, Triassic is the time period from about 250 million years ago to 200 million years ago. Tricia writes, can you explain what happened to form Crystal Rapids? Yeah, Crystal Rapids at River Mile 99 in the Grand Canyon was made a big rapid in the year of 1966 when about 15 inches of rain fell in a 3-day period on the north side of the Grand Canyon. And this caused a huge debris flow to come down Crystal Creek, and for a short period of time, a couple dozen hours, a big rock dam had formed all the way across the Colorado River. The river eventually took away most of that material so that there's a channel for the river, but many of those big rocks still are sitting in the channel there along the Colorado River. Let's see, T. Black. Since the Grand Canyon is close to the asteroid impact site that impacted 66 million years ago, is there traces of iridium? In the Grand Canyon, no. Our youngest rocks in the park are, Triassic in age. I think the closest place to the Grand Canyon where we have iridium layer at the Cretaceous-Paleogene boundary would be in the Raton Pass area of New Mexico. So we're a little bit far away from that. How many native tribes lived in the Grand Canyon? Gina is writing. There's 13 native tribes that work with the National Park Service and help in the management of Grand Canyon National Park. And their voices have been heard a lot more in the last decade or two. And in fact, the Grand Canyon Conservancy, which is the nonprofit that supports the national park, is now turning the Desert View Watchtower area into a native heritage area. And visitors to the Grand Canyon will soon be able to learn more about the native tribes that call the Grand Canyon home. There is still one group of Native Americans that live inside the Grand Canyon. That's the Havasupai Indians, and they live along Havasu Creek in the central part of the canyon. Beck writes, can you please talk about what the Great Unconformity is and how it was possibly formed? Yeah, I'd love to talk about that. The Great Unconformity is something that everybody has heard about in the Grand Canyon. And it is simply a place where rocks of two widely varying ages sit one right next to the other. So we've already talked earlier in this talk about these metamorphic rocks that are 1.75 billion years old, and sitting right on top of them is the Tapete sandstone that is only 500 million years old. So there's 1.25 billion years of the rock record that's missing where these two rocks come together. And if you do the Colorado River trip or hike down to the bottom of the canyon, you can go to a place where you can literally put your finger right on the contact there. So really the unconformity is just the product of erosion wearing down these very old rocks, leaving a rather featureless plain, and then new sediment coming on top and coming to rest on it. So an unconformity is a lot like a book that you might be reading. Of course, a book has page numbers, so you know where you're at in the book. But imagine you were reading a book and the page number 98, all of a sudden you turn the page and it goes to 201. Those pages are sitting right next to one another, and yet there's an unconformity there. Some of those pages have been ripped out, and that's what the great unconformity. Nate is writing, is there any place in the canyon where the Moenkopi Formation is still present? I've heard mixed claims at the top of Mount Sinyala in the canyon. Well, that's interesting. I have not heard of Moenkopi being on top of Mount Sinyala, but since I have the geologic map here, I can look right there, and no, there is no Moenkopi. I'm actually looking at the geologic map, and the Moenkopi has not been mapped on top of Mount Sinyala. The only two places near Grand Canyon where the Moenkopi exists is on Cedar Mountain, this little feature I pointed out here, and then also at Red Butte on the way in from the south side. Pat is writing, how was the formation of the canyon affected by the opening of the Sea of Cortez? Well, it probably was, the canyon was probably deepened by the opening of the Sea of Cortez. So when the San Andreas Fault ripped the Baja Peninsula off of mainland Mexico, it created a new ocean basin, and the lower Colorado River began to form and make its way down there beginning 4 million years ago. And once that happened, the Grand Canyon was probably deepened considerably by the opening of the Gulf. Now, I noticed you called it the Sea of Cortez. I know that no Mexican would call it the Sea of Cortez because they think of Cortez as being a bad guy, but Sea of Cortez is kind of a romantic name. Thank you for using that name just from a romantic point of view. Okay, Noah from Tucson is writing, what aspects of Grand Canyon geology do you think is the least well known? Are there parts of the usual geologic story that you think are wrong or is mostly speculation, etc.? Well, that's an interesting question. Thank you, Noah. The part of the geology that is probably the least well known is the timing of the cutting of the canyon. And there's a discussion about if some parts of the canyon might be as old as 50 or 60 or 70 million years, or if the whole thing was carved in the last 6 million years. That's probably what is the least known. But then relating to the second part of your question, is it mostly speculation or what do you think is wrong? You know, the people that see evidence for the canyon being 50 or 60 or 70 million years old, they have evidence for that in some parts of the canyon. And then there's evidence in other parts of the canyon that it's young. So this is something that's very interesting. When I did my first edition of Carving Grand Canyon, I thought to myself, how can it be that professional geologists who have studied this thing all of their life come up with such vastly different views on when the canyon formed? And it turns out by some recent work by Dr. Carl Karlstrom and others at the University of New Mexico and Northern Arizona University that some parts of the canyon probably are old, 40 or 50 or 60 million years, and other parts of the canyon are probably very young. So that doesn't mean that because different geologists see evidence for different things that the other side is wrong. It probably just means that a single human being can't see every aspect of the Grand Canyon. And it's a lot like that legend of the 6 blind men and the elephant. And each blind man is touching a part of the element and describing it correctly, but they can't describe the whole thing. And then if you remember that legend, the woman comes along and asks them what they're arguing about, and she says, you're all right. You're all describing a part of it, and together that makes the whole elephant. Thank you for that. Joe says, I heard a story years ago that a large boulder of Colorado River type sandstone was found off the coast of Southern California near Marina del Rey. Have you heard about that? I guess the only answer to that is no, I have not heard about that. But I'm wondering, Marina del Rey, that's a pretty flat landscape down there. We'll have to look. Robert, thank you for making the canyon come alive. I've dory boated the Grand Canyon and we'll do it again in 2021. You've supercharged my trip. Excellent. Enjoy the trip. Eric writes, do you know why the Colorado Plateau uplifted mostly horizontal without the compression and major tilting of most mountain building events? Very good question, Eric. There's been a lot of thought from researchers about the nature of the uplift of the Colorado Plateau, a pyrogenic uplift, this very gentle region-wide uplift. And it probably has something to do with the rock strength that underlies the Colorado Plateau. And it also has to do with the fact that there's been suggestions that a large oceanic plateau was subducted beneath the area where the Colorado Plateau now exists. And if a large oceanic plateau had been shoved under North America, that could also add to the rock strength. That's one way to think about that in a quick fashion. What do you expect the Grand Canyon to look like in the future? Thank you, Travis, for being a forward-looking geologist. I've found for myself that I'm often living in the past and not too concerned about the future, but as it regards the Grand Canyon, I have thought about this. The Grand Canyon at its very top part is 3,100 feet above sea level. That's about 1,000 meters. And then in the Phantom Ranch area in the center, it's about 2,500 feet, or about 700 meters above sea level. So the Colorado River still has the potential to cut deeper into these rocks. But you have to remember that the Colorado River in its entire length has its halfway point in the upper end of the Colorado River. So it still has to have somewhat of a gradient to get those extra 700 miles down to the sea. So the potential exists. If we have future uplift of the Grand Canyon region, which is possible and possibly even likely, then we're going to raise those rocks to a higher elevation. The river is going to be able to chisel down through them. And who knows, in the future we might even see a more spectacular Grand Canyon. But of course, eventually the Grand Canyon will be destroyed. And it's probably going to be destroyed by faulting that is creeping its way in from Nevada and beginning to break up the flat layers. And there's two great big faults in the western part of the Grand Canyon that run north and south, called the Hurricane Fault and the Toroweat Fault. And they're beginning to break up the layers, and it's thought that maybe those stresses and forces will begin to eat their way into the Grand Canyon region. Okay. Geology is a book of time. What do you expect the Grand Canyon River corridor to look like in the future time periods? I think it's going to stay trapped in that Vishnu schist and Zoroaster granite, but it might become deeper if the river chisels down into future uplift. Don't touch your... Oh my God. I did wash my hands before this. When the shales erode back faster, do they undercut the overlying formations which are brought down by gravity? That's by Robert. Yes, that's exactly right. Because the Bright Angel Shale is being stripped back away from the Colorado River, it's undercutting the overlying layers that are at the top. And so these hard layers, which would normally stay close to the river's edge, even if they're up high away from it, they're being undercut and they collapse. And that helps to form platforms as well. Let's see, Peter's writing, can you talk about early mining efforts in the Grand Canyon and why there was not any bonanza of mineral riches despite some successes with copper and uranium? Is it possible there are mineral riches that have not been discovered? Thank you for that question, Peter. The chances are not likely that mineral riches will be discovered Although the people that work with the uranium at the Grand Canyon call those bonanza grade. They're very small deposits, but there's lots of them, and they're very high grade. So I guess you could call the uranium bonanza deposits, but they're scattered all over the place in these features called breccia pipes. Again, you might have missed the discussion earlier, but intelligent miners always say gold is where you find it, and the Grand Canyon is not one of those places. Jason writes, along the trail of time, there are many examples of Precambrian microbial structures. Is there any ongoing research into this early life? Yes, there are people who are studying this microbial life, and they have discovered many species of these blue-green algae that lived back 700 or 800 million years ago. They've given species names to these, and they have been studying them. Chris is writing, could you explain why the Schnebly Hill Formation, so present near Sedona, Arizona, did not make it up to the Grand Canyon? That's correct. There is a place in Sedona, Arizona. All of Sedona, Arizona has a rock unit that in the Grand Canyon is not present. And it's true that for all of the rock layers during this specific time period, about 280 or 285 million years ago, the rock units all thicken to the south. And that means they thin to the north. So just north of the Grand Canyon, the Coconino sandstone pinches out entirely. And at the Little Colorado River in Grand Canyon, it's 500 feet thick. So during this period in geologic time, areas to the north of what is now the Grand Canyon were sitting relatively high above the landscape, and there was a basin that was forming to the south. So these rock layers get thicker as you go to the south because there was more space for sediment to accumulate to the south. We're going to talk about a lot. Andy Frank, can you talk about the lava dams? Yes, this is one of the most exciting stories in the Grand Canyon. As if the Grand Canyon were not enough of a special place, beginning about 800,000 years ago, lava began to erupt on both rims of the canyon and spill into the canyon, into the Colorado River. So we have numerous lava flows that have filled in these old canyons completely and caused these old canyons to carve new courses for themselves. And in some instances, even the Colorado River had to form a new course for itself. So the lava dams were created 13 to 17 different times in the last 800,000 years. So much lava spilled off the rim that it blocked the river. If the dams were strong enough to last a long time, water would have been backed up in the Colorado River and we would have had these natural reservoirs in the Grand Canyon. But eventually the dams would be destroyed either by blowing out at the bottom of the dam or by water pouring over the top. I just imagine if you could go back 500,000 years ago and be camped on the rim of the canyon and watch red hot lava at night pouring down into the river. And then imagine a dam forming along the river and seeing the reservoir behind it. And then imagine you happen to be at the same campsite when one of these lava dams was destroyed catastrophically. And that did happen on at least 5 different occasions. There is evidence for 5 outburst flood deposits that have been found in the Grand Canyon where some of these dams failed catastrophically and momentarily. And some of these deposits have been found 600 feet up from the modern river with boulders as big around as 100 feet or 30 meters in diameter. The lava dam is very. Todd is writing, isn't it super rare for the Colorado Plateau to uplift as a single unit with little to no tilting or faulting? Anywhere else in the world that this happened over such a large area? It probably has happened and is happening at the Tibetan Plateau just north of the Himalayas. And there the edge of India is being shoved under Asia. And because that's continental crust that's being shoved under, it wants to be buoyant and it raises up and it's lifting up the Tibetan Plateau. The Tibetan Plateau is an example of an area that might be experiencing this aperigenic uplift. But again, it's the type of material that's being uplifted that determines whether it comes up as a single unit or is chopped up like you see perhaps in the Basin Range of North America. I can see that people are writing to other people and answering some of these questions. I thank my fellow geologists for doing that. What books might you recommend for further study of the geology of the Grand Canyon? I can recommend a few things. There's a new book that has just come out by Dr. Carl Karlstrom and Laura Crossie. It's called The Grand Canyon Trail of Time Companion. And if you do go visit the Grand Canyon, be sure you do the Trail of Time walk on the rim. There's incredible information and diagrams in here that will teach you about the geology of Arizona and of the Grand Canyon. You could also look at my book, Carving Grand Canyon. This is a book that's strictly about the evidence that has been found for how the Grand Canyon was formed. This is not about the rock layers, but it is about the carving of the canyon. And then a companion to that would also be Ancient Landscapes of the Colorado Plateau, which is about the rock layers. And this is the book that has all of these paleogeographic maps of the Colorado Plateau. There's 70 of these maps in here, and you can see what the ancient geography of the area was through all the span of time that the Grand Canyon represents. And finally, if you want a really good primer on geology, there's this book that I'm an editor on, The Grand Canyon Monument to an Ancient Earth. Now the subtitle says, Can Noah's Flood Explain the Grand Canyon? Because a portion of this book shows while the biblical story of Noah's flood cannot be responsible for the carving of the Grand Canyon, there also is a lot of information in this book about what geology is and why geology can inform us about the history of the earth. And I see we've come to the end of our time here. I want to thank my sponsor, Muhammad Qasim Mahmoud, who has facilitated this live session. And again, I'm so interested that all of you, it looks like we had 225 viewers, lots of questions that I didn't get to, but I want to thank you all for tuning into this. And remember, wherever you go, there's a geologic story. The important thing is just to observe. Whether you know what's happening or not, it doesn't matter. Just to look at it is the reward. Thank you very much. Bye-bye.